All right, so today we're going to talk about how the heart beats specifically with relation to electricity. So obviously it's not electricity that is traveling through your heart, but these electrical signals that travel through nerve fibers. All right, so let's define a word right now. And that word is myogenic. Myo is a word that refers to muscle. And this word in particular means that the signal for the heart to beat comes from the heart itself, not from the nervous system. So the heart can beat on its own, which is really, really, really interesting. Remember that these cardiac muscles are branched so that the signals can travel a little bit faster. And also remember that these muscles are attached by these things called intercalated discs. So these intercalated discs are kind of like little strainers. Like a strainer that you would use on your spaghetti or your macaroni, is a piece of metal, and it's got a bunch of holes drilled through it, and that allows the water to travel through it faster. Well, it's like that in between these cells. This intercalated disc is a connection between cells that has a bunch of holes in it, and that allows the signal to travel from one cell to another. And so these intercalated discs are really important at allowing the heart muscle to send signals to other cells. Without it, the signal would have to jump from one cell to another. But instead, these cells are connected to each other by this disc that has holes in it so that the signal can travel better. So your heart knows how to beat consistently because it has special cells that are referred to as pacemakers. And these pacemaker cells control and coordinate the contraction of the muscle cells. Let's do that down here. So pacemakers are groups of cells that coordinate the contraction of the heart muscles. You know that people can get pacemakers put in them. Those are little artificial things that control the contraction of the heart. But these pacemakers that exist in your heart right now are bunches of cells. So our first pacemaker is called the SA node. That's our first pacemaker. So this is a bunch of cells. SA is short for sinoatrial. So this bundle of cells are the first set of cells that will control the rate of the heartbeat. This triggers about 60 to 100 contractions per minute. I'm going to put CPM, that's contractions per minute. You could think about that as beats per minute as well. And those are normal heartbeats, is what that's called. Those are normal heartbeats. So this is the primary pacemaker. If this pacemaker goes down, your heart can still beat using a second pacemaker, but not as much. If this goes down, this is a problem. So it's the SA node sends out these electrical signals, which are propagated through the atria, through those intercalated discs. Wow, I just said a whole bunch of stuff there. So The SA node, and let's write it right up here, sends out signals that are propagated. Remember that from yesterday's notes. Through the atriums or atria via those intercalated discs. So that means that, and I'm going to go down to my cardiac muscle picture here, that means that when a signal, let's say, starts here, the signal travels through these cardiac muscle cells by passing through those intercalated discs. And remember, propagated is kind of like saying that one signal triggers the next, which triggers the next, which triggers the next, and so on and so forth. And so you can see in this picture right up here that the SA node is located just above the right, or just right above the right atrium, and that this signal travels through these cardiac muscle cells here, all the way throughout the atriums, and this ensures that the atrial walls contract like simultaneously. So the right and the left atrium contract at about the same point. I love this other picture over here for another reason. Over here on the right, and you can see that the signal travels over to the left atrium, and everything then goes on. Now, the atrium and the ventricles are separated by this kind of fibrous connective tissue layer, which is indicated by this dotted red line here. So this is really important because we don't want the signal to travel down to the ventricle yet. We want it to stop. And this connective tissue layer helps to keep the heart valves in place, but it can't conduct these electrical signals, which makes sure that the signal just doesn't go right down to the ventricle. Because if the signal was to travel right down to the ventricle, then the ventricle would pump before the atrium could even fill up. And so this pause that is caused right here in the signal, it allows the atriums to contract completely. To fill up the ventricles. Your heart wouldn't be very efficient if the atriums pumped so quickly that the ventricles couldn't even fill up before they pumped. That would not be very effective. So this pause is incredibly important. So now that signal this signal from the SA node is going to eventually travel to our second pacemaker, which is the AV node. AV is short for atrioventricular node. The atrioventricular node. Now this AV node sends the signal a little bit more slowly than the SA node. This helps to create a delay. Because the signal travels slower. And that, once again, that is to allow the atrium to completely empty down into the ventricle before the ventricle pumps. Okay, so this second node, this AV node, this is our second pacemaker. It sends a signal down through these two bundles of electrical transmitters here. These are nerves, and these are called the bundle of His. There's a left and a right one. Now, this bundle of His right here doesn't make the ventricle contract yet. It's just traveling down here. And once again, this is that pause so that the atrium can completely empty out, which is incredibly important. So the atrium is going to completely empty out so that the ventricles can be filled up. The atria are then going to relax. This is just right from our notes from yesterday. And then the nerve fibers that branch off of the bundle of His are called the Purkinje fibers. And these Purkinje fibers are going to carry the signals that cause the ventricle to contract. Remember that contract means that the muscle shortens, so it squeezes. And this causes the blood to flow up and out of the arteries. If it's going from the right side of the heart, it's going out of the pulmonary artery to the lungs. If it's going out of the left side of the heart, it's going out to the aorta, which then travels to the rest of the systems of your body. All right. So I said a lot. I wrote on a lot of drawings, and it's important, I would say, to rewatch this video to make sure that you understand what's going on in the heartbeat. And tomorrow, those machines that are on, you see them in all the hospitals, and it's got the screen, and the heart goes beep, 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 beep. We're going to learn how that is a measure of these electrical signals tomorrow. All right, that's it. Take it easy.